All right. Our next speaker is Robert Brewer. He's the CherryPy lead developer, and he's going to talk about how CherryPy supports Python 2 and 3.
Okay, great. Thank you. Welcome, everyone. I am going to talk about Python 2 and 3, and hopefully inspire you to think about the problem perhaps a little bit differently than you have in the past. There's going to be, this isn't going to be a talk that's really long on the exact details of what's different between Python 2 and 3, because number one, you can go get that on your own somewhere else much more easily than I can tell you. And number two, as you might notice, I'm actually not a programmer anymore. I'm an architect, which means I am not supposed to care about details. And in fact, if you watch the entire talk, you'll notice that I don't actually have any code in here either, because I don't code anymore. So, architects were like that, so that's part of the fun. So what we're going to do is not go that fast here. You might notice that I actually don't even have a computer anymore. I'm doing this from my phone. So we're a weird bunch. So I'm going to show you not how to port from Python 2 to 3, but I'm going to show you and suggest that you support both Python 2 and 3 at the same time. Now, if you have if you just have an application that you're responsible for and you deploy it to one data center and you only care about one version of Python anyway, I mean, great. You're gonna be running it in your data center in 2.6, and someday you're going to say, we need to go to 3. Whatever is current, and you'll just port it, and that's great. But if you have a library or a framework or any kind of thing that you distribute to lots of people, you're going to want to support Python 2 and 3 for a number of years to come. So hopefully I'm going to show you how to do that in just 4 easy steps. Quick poll, even though there's not a lot of folks here. How many of you have actually not done any Python 3 work yet at all? Great. You are in the fun camp, okay. How many of you have done some work, maybe porting a piece of code to Python 3? Okay, and those of you who have your hands up, how many of you have finished that process? Okay, and those of you who still have your hands up, how many of you have actually released something in Python 3? And how many of you have actually deployed something in Python 3? Oh, I see one hand. A couple, okay. And you folks who have actually deployed something, how many of you have actually gone through a bug fix cycle after that and gotten bug reports and then had to go back and fix things? Oh, there's still a couple, okay, okay. So, all of you folks who have actually done some work porting to Python 3, I just want to start by saying, go back and start over after you see this talk, okay? Those of you who haven't started at all, you are in a great spot because you get to learn from all my mistakes, okay? So, I'm going to show you 4 easy steps. First step is, great, go and read everything you can. Read Guido's What's New in 3.0 document, go read Brett Cannon's How to Port guide, go read Lennart's great book on porting, go read all the blog posts you can. Read everything you can because you really need to understand this problem before you start. Now, you're going to go read these things, and you really have to be careful here. I'm actually not giving you a lot of links to what to go read until at the end of the talk, because I want you to pay attention to me and not be surfing the web on your conference fee here. So you don't have to read copyright law. I'm probably going to want to read that by the time I'm done with my talk. But you guys go read everything you can about how to port, okay, and how to support Python 2 and 3. But when you go and read all those guides, you're going to find out that they're all wrong, okay? So take them all with a heavy grain of salt. They are wrong in at least one point, which we're going to get to here. So what they are right in is that they all say step 1 is go test, right? You must have a robust test suite if you want to be successful at this. If you don't, I can guarantee you that you will have at least one bug in production that will bite you, and it'll be some code path that you thought got fixed and didn't actually get fixed. I can guarantee that even if you do have a robust test suite, this is going to happen to you. But at least if you have the test suite, it will be, catch all the easy ones, right? So go test, just like that. Administer the test, right? And you're gonna find out that it's easier to do this if you do your test suite first. Don't go and try and make all these changes and then write test suite. Write the test suite first, okay? So those are kind of the easy first couple steps. Quickly, just why is CherryPy a good source for how to do this? It's because we've tried it 4 different ways and failed at least 3 times, right? But CherryPy has some other good qualities about it that make it a really good learning experience for how to do this right. There's a few things about CherryPy that it's really the worst of all possible worlds. Not only do we start off with, a lot of the guides will say, well, get your code up to 2.6 and then try porting to 3.2 and don't support anything less than 2.6. That is complete bunkum. You can support any version you want, and CherryPy really tries to support, wait for it, 2.3, all the way to 3.3 and beyond, and we do it successfully. Another good reason why CherryPy is a great example is because we do a lot of non-blocking socket I/O. Now, I/O is one of the things that changed pretty heavily between 2 and 3. It's not just a name change. They actually have entire new modules and new ways of doing I/O. And not only are we doing I/O and have all these changes to deal with in the interface that we're calling, but we're doing non-blocking I/O, which the standard library does not provide. So we already had our own subclasses of standard library classes. And not only did we have our own subclasses, but we had subclasses of classes in the standard library whose names start with a little underscore, which means they're private, which means we shouldn't have been subclassing them, but we were, in order to get work done, right? So it's a great example for that. There's 2 other things that have to do with encoding mostly. Now, the big change from Python 2 to 3 is obviously bytes were the native string type, and now Unicode is the native string type. CherryPy has some particular difficulties in this area because it speaks HTTP, and HTTP is itself underspecified when it comes to encodings. There are headers, for example, that you can receive in an HTTP request where it is impossible for the sender of the message to specify the encoding of the data they're sending to you. So not only do you get wrong encoding sometimes you don't get any encoding at all, and you just have to either say, well, I trust the client is sending data in the encoding I expect, or you just guess, right? And then also it speaks WSGI, and so that's a whole other layer of things. Now WSGI, when it got ported to Python 3, introduced this concept of native strings. Native strings are a really great idea because it's a great way to think about how to have a single code base, for example, where you're supporting both Python 2 and 3. Again, byte strings versus Unicode. But it's just another layer of having to deal with the way people want to think about things. WSGI was not easy. And then finally, CherryPy is kind of unique in that it tries not to have any dependencies whatsoever. So there's a beautiful module out now called 6, which we'll talk about a little bit more in a minute. But CherryPy can't import it because we kind of have a policy of being the trunk of your import tree. So we don't want to import 6 and depend on it. So step 1 was read. Step 2 is test everything. And now step 3 is run the 2 to 3 tool. If you haven't seen the 2 to 3 tool yet, it's included in recent versions of Python, both Python 2 versions and Python 3 versions. It's a command line utility typically that you'll run from your terminal and say Python 2 to 3 my code base. And what it does is it takes all of your code. It actually creates a parse tree after trying to analyze everything. And then it runs a series of transformations that take the Python 2 syntax, and then out the other side comes a set of Python 3 files. Most of you have probably heard of that or seen it. The problem with 2 to 3 is that it really falls in the don't make me think camp, right? And it kind of has to, because there's a lot of changes between Python 2 and 3. And really the low-hanging fruit is the syntax changes, right? 2 to 3 is great about that. It's a wonderful module. It will detect that a module has changed names in the standard library. It'll fix that for you. It will detect that you have a dictionary and you're calling the iterValues method on it. And now in Python 3, that's just called values to get the same semantics. It'll change that. Does all kinds of great things like that. It'll get rid of the little U prefixes on your strings, those kinds of things. But really, it's almost entirely limited to syntax changes. And there's going to be a lot of semantic changes, not just between Python 2 and 3, modules you're importing, but in your own code because chances are that you've probably been doing things, especially with bytes in Unicode, that are less strict in the Python 2 way, and now you have to be more strict about them under Python 3. So that's a little bit difficult. So what I recommend is that if you run 2 to 3, and you should, after 2 to 3 runs, check every single change that 2 to 3 recommends, and either approve it or reject it, and then check everything that it didn't change, because there's going to be some changes that you have to make as well, just manually. And then, run your tests. Now, there's some other problems with 2 to 3. And the problem with 2 to 3 and some of the guides that you might read out there is that they say, okay, we don't want you to just run 2 to 3 one time. We want to automate it. We want you to be running 2 to 3 all the time. Or what a lot of them will say is, we want you to take 2 to 3 and run it at the moment the user types python setup.py install. We want it to run on the user's machine, and it will take your Python 2 distribution and create a Python 3 distribution at the point they install. Back in the day when everybody was like in Cubby farms, we called this throwing code over the wall. So I think you can imagine who's going to get hurt if you throw this kind of a change over the wall. It's not just a new feature. You're transforming your entire code base, and you're going to run into problems. So of course, you're going to go through a long process of testing all these changes yourself before it ever gets to your users. But the problem is that it's not just a problem for your users. It's going to be a problem for you in development, because as you're testing all of these things, you're going to find out that, as Nick Coughlin said the other day, this is basically adding a compile step to your development process in Python. And adding a compile step to a Python development process sucks. You don't want to do it. Or you want to do it as little as possible, right? So I really recommend once. And then the other problem is that it's not a particularly fast compile step. There's plenty of anecdotal evidence that even prompted a very recent PEP, which says that, for some of these people who are doing this porting process, that the 2 to 3 part of building a package and distributing it is actually, it takes longer to do the 2 to 3 transformation than to run their entire existing test suite, on the order of 10 times slower. So good reasons to avoid going from trying to run 2 to 3 all the time, right? Not to mention that you have, you're going to find things that 2 to 3 doesn't fix, and then you're going to say, well, how do I get those to happen every time? I'm going to write a custom fixer for 2 to 3. So you're going through the work anyway to do all these custom fixes, right? So I really recommend that with presentation software that doesn't work, I really recommend that you, 2 to 3, you treat it like something where you're making an initial stab at the problem, right? And then you check everything that it changed, and you check everything that it didn't change, and then you run all your tests, and then you go back and you check your tests, because chances are they're actually not testing what you think they're testing in Python 3, right? And then you put 2 to 3 back on the shelf. It's a great tool, but run it once. So step 1, read everything you can. Step 2, test everything you can. Step 3, run 2 to 3, but only run it once. So if you only run it once, what are the options that you have for distributing stuff that works on 2 and 3? Well, for CherryPy, our next solution was, well, let's try the separate branches approach. There's a number of guides that recommend this might be a great way to go. And so we tried this. Our whole, I believe it was the 3.1 set of versions, tried separate branches. And we were on Subversion at the time, which is actually a good thing. And we had our trunk that we had been developing, and we said, let's start a new branches/Python 3 branch. And that was a reasonable solution for about 2 days. The first thing that happened was, okay, now we have 2 different branches. What does that mean? That means we are packaging and distributing 2 different packages of CherryPy, right? And so what happened was we would start to get these bug reports, IRC, email, wherever, that said, hey, I was trying to install CherryPy, and I got the CherryPy version for Python 3, and I'm installing it, and it's not running. Or I can't even install it, right? And what we found was this weird mix of things with mismatched Python environments, especially with people who had both Python 2 and 3 on the same laptop or wherever they were installing, because they would either install they'd be trying to use Python 2, and they'd try to install the package for CherryPy 3. Sometimes because they were using the wrong easy install binary, executable, right? And then the other problem that happened all the time was they would actually install the package in the correct environment. So great, I have Python 3 with CherryPy 3 installed correctly in it now. But then they would try to execute some script of theirs, and they'd be using the Python 2 executable by mistake, right? So this was just really confusing for everybody. And we had some problems, other unrelated problems with like Windows installers installing the wrong versions and things. But there's a more insidious problem with running separate branches, and that is, how do you actually do it? You've got developers, and they are submitting patches. Number one, it's really hard to train your developers. We had a number of people who were contributing, and they would submit, just the Python 2 fix, but not the equivalent Python 3 fix, because they either didn't know about the fact that we had a Python 3 branch, or they just assumed it was somebody else's problem, which turned out to be me. And so I said, well, I know how to solve this. I'm going to just apply this patch that they submitted for Python 2. I'm going to apply it to the Python 3 branch, which is great, again, for about 1 or 2 fixes, until you get to the point where you say, well, no, the work I did yesterday or last week, I want to go back and look at that again. It's not really fresh in my mind anymore. And you might try to figure out, well, not only did I make a change to Python 2, but I made a change to my Python 3 code, but sometimes that's exactly the same change, and sometimes it's actually different because it has to be different to support the 2 different code bases, right? So there's a subtle problem of, well, now how do I look at the differences between differences, right? And it becomes this really hard problem to solve. And the way I tried to solve it was, well, of course, now I'm going to use meld, right? So I pull up a graphical meld window, and I've actually got 3 windows because I've got the previous code in one, and the Python 2 change in one window, and the Python 3 change in another window, so I can kind of compare them side by side. But even with that, it's hard to compare those patches because the majority of the patch is going to be stupid little syntax things like, now you've got a little B prefix in front of your string, or you've lost the U prefix, or you're calling a different, module. And it's things that 2 to 3 fixed for you automatically, but now you have to look at those changes all the time, side by side. And it gets really hard to see exactly what the meat of the actual patch was sometimes. So that's just really hard to do. And then what you find yourself doing is you actually you find yourself saying, well, that's really hard, so let me minimize the actual differences, and you end up writing Python 3 code in Python 2 or Python 2 code in Python 3, and you try and get rid of all those things anyway. So you're almost writing a little compatibility layer as you go through these patches, right? So we stopped doing the separate branches, and we said, hey, we're writing this compatibility module anyway. Why don't we just ship a compatibility module, and now we can have our code run the same code base on Python 2 and Python 3. And it turns out that this is actually one really honking great idea. We should do it more. There's lots of benefits to this. The biggest benefit is that not only can you support the major differences between Python 2 and 3, you use exactly the same techniques to support minor differences, let's say 2.3 to 2.4. I mean, you all remember, some of you remember when 2.4 came out, and now we have decorators, and everybody was all, oh, that's a horrible backwards incompatible change, and how are we going to upgrade our code? Well, the great thing is that you don't have to upgrade your code just because you moved from 2.3 to 2.4. And what I mean is, just because decorators were allowed in 2.4, we didn't force the people who are using CherryPy to start using decorators everywhere. We provided some of them, but we didn't force them. We actually used the old syntax. For most of the changes between Python 2 and 3, you can use just a single module, and ours is just, I think it's like 200 lines long in CherryPy, that you do simple things like try and import the Python 3 module. And if that gives you an import error, then import the Python 2 module. And then we have some wrapper functions, for like, well, if I If I have a dictionary that I want to iterate over the values of that dictionary, then you write a little wrapper called iter values and pass it a dictionary. And that works in Python 2 just as well as Python 3. So you put all those little differences into one little module, right? And ours is just called under cp compat.py, but you can call it whatever you want. And the cool thing is not only do you get the chance to control the differences between major versions and minor versions, but with exactly the same techniques, you support Jython, IronPython, and who knows, maybe even PyPy in some ways, right? Or whatever other weird kind of Python people are coming up with, which we were doing anyway. We already had hacks for Jython and IronPython, etc. So there's lots of pros to this approach. You don't have the merge hell. You support all these versions, 2.3 to 3.3 and beyond. You have everything collected in one place, and it's really not that bad. The one bad thing is, of course, well, now we're writing not idiomatic code, right? It's off-model, as they would say in the Simpsons world. So you get code in your library or your framework that looks a little dated, maybe, And sometimes you're importing these functions that maybe a new programmer would kind of balk at that and say, well, that's not standard Python because you're using these wrapper functions and so on. But really, those problems are not problems. They're not problems we need to solve because they don't affect anybody except the authors of your library or framework. They don't affect your users. You don't have to change your API just because you are importing a different module behind the scenes. All of this ugliness is entirely contained within your package. You don't have to change anything about the way your users are interacting with your product, number one. Number two, the changes are they're appropriate. You have these changes that make sense. Like when we get to start talking about Unicode in just a minute, then you're going to see that we're actually following the strict Unicode approach of Python 3, and our code is more understandable now that we're using these techniques than it was before. You also don't have to worry about, well, I'll get to that later. The cons are really limited in their scope. And wonder of wonders, for most of you, you will find this wonderful module called 6 at some point, Benjamin Peterson's great module, that has already done all of this work for you. It already has all of these wrapper functions. It already has all of these try, except, import the right module kind of names. And all you have to do is import 6 and use the names that it already exposes. And it actually does it in a really intelligent way. It doesn't give you a real module. It gives you kind of a fake module. And when you go to import something, it's only at the moment that you try to import something that it goes and loads it. So it's not like you have to load up all these modules you're never going to use, right? So 6 is great. We did not use it for CherryPy. We wrote our own because we don't want to depend on anything, but I highly recommend 6 for anybody that's doing this. And then just one last minute on string literals. This is a great example, and it's the one thing that might confuse you a little bit, and I have one more recommendation. Bytes to Unicode is the biggest change in Python 3, especially if you're doing any kind of I/O. There's been lots of approaches recommended to this for handling this. You could do the future import, but that only works if you're using Python 2.6 or higher, which we weren't. You can use, now with PEP 414 being approved, Python 3.3, which is just now in alpha in the last week or so, has reintroduced the U prefix on strings. So you can use B and U prefix literal strings in both Python 2 and 3 again, but only if you're using, you can't target Python 3.0 or 3.1 or 3.2 then, right? A lot of people before that came out were using little B and U functions that wrap things up. That's great too, except they all have fixed encodings. They were all just using Latin 1 or ASCII, and that's not good if you are using other encodings. Or maybe they were using UTF-8. And in HTTP world, you have to use ISO 8859.1 all the time for headers and things. So we couldn't use that. So what we used, and what I really recommend to you, is make your own functions like the B and the U but provide an optional argument to specify the encoding, both in and out. This has really cleaned up the HTTP server in CherryPy, because before, there were a lot of strings that we were reading and emitting that we just did not know the encoding of. And now, every point in the server, it has to be explicit. This, basically we're saying, by this kind of declaration, this string has to be able to be encoded as Latin 1, or ASCII, or whatever is appropriate. So our code is better documented with this approach. So that's pretty much it. Read, test, run 2 to 3 once, and then write a compatibility module and use it everywhere. And your life will be simple from that point on. I wish we had done it before we ported to Python 3, and then getting Python 3 support would have been a couple days of work. So for the win, use that. Here's links. Any time for questions? We have a little bit of time for questions, but I warn you, again, I'm an architect, and I don't do details, so.
So it seems to me that CherryPy is in a position where performance matters when you're an HTTP server, and I'm just wondering what your observations were with the N2B and N2U functions and wrapping all your string literals. Did you see an impact there? Are users of Python 2.7 suffering due to the port in a performance sense, or not really?
That's an excellent question. The performance of CherryPy using these kinds of approaches, with this compatibility layer and running through all this, we actually did not see a significant difference doing the conversions ourselves where we needed to do it. Where we did see a significant difference was when we tried to use some of the standard library tools that move, for example, the incoming payload, which is bytes. They tried to translate it to Unicode earlier than we wanted to. And we didn't want it to happen at all, really. And so there were some things like that really kind of tripped us up. So the conversion will trip you up if you do a lot of I/O and are not careful about exactly when and where you do the conversion.
What did you do about those standard library APIs? Did you stop using them and re-implement your own versions? Or?
That's why we subclassed and wrote our own version.
Okay.
One of the reasons.
Do you have any advice about extension models and things like Python? And
I do not. Those are details, and it almost sounds like code, and I'm an architect, and we don't do that. So.
Do you know if 6 comes with a 2 to 6 script or anything like that? Since it seems
if it comes with what?
With a 2 to 6 script instead of a 2 to 3 script.
I do not know.
Yeah, Python Modernize.
Yes, Python Modernize. Yes, that's the one. I recommend that as well. The one thing I forgot to mention about the 6 module is I don't personally know what versions of Python it supports. I think it's fairly broad, but I doubt it goes back to 2.3, for example. So take that with a grain of salt as well. No more questions. Thank you very much. Have a great day.